Hello everyone. So let's discuss problem number 16. Seven identical planar discs, each of mass m and radius r, are welded symmetrically as shown right here. The moment of inertia of the arrangement about the axis of normal to the plane passing through the point P is, and this is the point P, right? So let's see the solution for this. So we have to find moment of inertia about the axis normal to the plane passing through P. Right, so first we'll find the moment of inertia about the center, that is O. Right, it goes as the moment of inertia of the central disk is mr square by 2. I hope you're familiar that the moment of inertia of the solid disk about its center is always mr square by 2. So in this case also, the moment of inertia of the central disk about its center center is mr square by 2, plus we have 6 other disks surrounding it. So the formula for finding the moment of inertia of an object away from the center is the moment of inertia around the center of mass, that is about point here, that is would be mr square by 2 plus mass into the square of the distance from the center, that is r and r. If I say it correctly, the radius is r, right? So we have it value r, and this is also r, and all these 6 disks are at a 2r distance from the center origin. Okay, so it would be 6 times mr square by 2 ICM plus m into distance square, that is 2r whole square, right? It would sum to be I naught is equal to 55 by 2 mr square. Now we see this is the moment of inertia around origin, okay, of the whole figure. We have to find about this point P. Now using the parallel axis theorem. The parallel axis theorem says when we have to find an moment of inertia about a parallel axis, what we do is we add the mass, total mass multiplied by the distance squared into the moment of inertia around the center of mass, right? So that's what we'll do right here. This is I naught, so we'll add about IP will equal to I naught plus 7m, 7 is the total mass, 7m into 3r, that is 1r, 2r and 3r, right? So 3r whole square gives us 55 by 2 plus 63 mr square. Taking the LCM and adding them up would give IP equal to 181 by 2 mr square. Hence the correct answer is 181 by 2 mr square.